Welcome back students to DAV GUMLA online enrichment classes. Today I am going to deal with a special topic. It is limit with infinity. How to find the limit of certain functions when x approaches to infinity, right? So this is our topic today. It is very important one. Before starting, let me talk about the graph. What I want to say is when limit x approaches to infinity, 1 by x must be equal to 0, right? How it is? Let me first show it graphically. Graphically, if I plot the graph of fx equals to 1 by x, then the graph looks like this. It is a hyperbolic function. It completely looks like a hyperbola. Here this side as well as this side. Now here you see this is 0 and this part will be infinity. When our x approaches to infinity, this is the value of fx. Fx is tending to 0. So when x approaches to infinity, it is 0, or when x approaches to minus infinity also, the value at this point, look at this, right? This part also becomes 0. So this is our important relation, that limit x approaches to infinity, 1 by x must be equal to 0. So using this, first we will solve certain of questions, and then I will proceed for the formula regarding limit when x approaches to infinity, right? So let us see. To begin with, let me take up one question. Now remember, if I take x approaches to infinity, suppose I will ask you, this is limit x approaches to infinity, this is 5x minus 6 divided by square root of 4x square plus 9. So in this question, our first job is to convert or bring 1 by x, because I can find the limit only when I have 1 by x. So what I do is divide the numerator and denominator by x. So this will be our step. Limit x tends to infinity, 5x minus 6 divided by x whole divided by under root of 4x square plus 9 whole divided by x, right? I have divided numerator and denominator by x. Clear? So now let me proceed to the next page. So what I will get? It will be limit x approaches to infinity, 5x by x, it will be 5 minus 6 by x, right? That is limit x approaches to infinity, and I was having 5x minus 6 divided by x, and here in the denominator, I will talk about the denominator later. Now you see this one, I will simply write it as 5x 5 minus 6 by x. Now in the denominator, I was having 4x square plus 9 divided by x. So first thing is, what I want to write, I can write this one as a square, and I can extend the square root here. This is complete square root of 4x square plus 9 divided by x square. Now what I will get here, 4x square by x square, it will be 4 plus 9 by x square if I simplify. So let me do it again. So it will be completely square root of 4x square plus 9 divided by x square. So if I split this one, I will get it like this, 4 plus 9 divided by x square. Now let us put the limit. If I put a direct limit, 5 minus 6 by infinity, under root of 4 plus 9 by infinity. Infinity square is also written as infinity. Infinity square, you should write it as infinity. Now 5 minus 6 divided by very large number. Infinity is a very large number, so the value is 0. Whenever infinity is in the denominator, the value becomes 0. Divided by square root of 4 plus 9 by infinity is again 0. So this will be 5 divided by square root of 4, which is equal to 2. So the answer will be 5 divided by 2, right? So this is how we solve the related questions to infinity when our limit x approaches to infinity. Clear? So what we learned in this question is, first thing is try to bring 1 by x in all the questions, right? Let me take another type of question. If I take, this is limit x tends to infinity square root of x square plus x plus 1 minus square root of x square plus 1, right? So now my question is, I have to bring 1 by x here. How to bring 1 by x? This is a bit challenging. Please see the technique carefully, right? What I do, in this type of questions, remember square root will definitely be there, so it is in the form of radicals. If it is in the form of radicals, try to rationalize by multiplying suitable quantities in the numerator as well as in the denominator. So what I get is limit x tends to infinity under root of x square plus x plus 1 minus under root of x square plus 1. I will multiply it with this one, under root of x square plus x plus 1 plus under root of x square plus 1, right? Whole divided by, if I have multiplied the same thing in the numerator, I have to multiply the same in the denominator. That is under root of x square plus x plus 1 plus under root of x square plus 1, right? Now you see, the numerator is in the form of a minus b whole into a plus b. The formula is a square minus b square. So if I take the square of this term, the square of first term, that will be x square plus x plus 1 minus square of second term, that will be x square plus 1. Root will be removed. Whole divided by under root of x square plus x plus 1 plus under root of x square plus 1, right? Now see the numerator, right? In the numerator here, x square and x square will get cancelled, 1 and 1 will also get cancelled. I will only have x in the numerator, and in the denominator I will have the same term, right? So that will be equal to limit x tends to infinity. In the numerator only x will be left, and in the denominator the things will be x square plus x plus 1, then plus under root of x square plus 1, right? So now what I will do is limit x tends to infinity. Now what you do, divide the numerator and denominator by x again, right? So what I do is x divided by x. Now this is under root x square plus x plus 1 plus under root of x square plus 1 whole divided by x, right? So apart from writing x, what I would like to suggest is write it as x square, square root of x square, right? And divide it both sides, that is under root of x square plus 1 by under root of x square plus under root of x square plus 1 divided by x square, right? So our next step will look like this. That is equal to limit x tends to infinity and x by x, it will be 1 in the numerator, and in the denominator it will be under root of x square plus x plus 1 divided by x square plus under root of x square plus x square plus 1 divided by x square. So the things will look like this. Limit x tends to infinity, this is 1 divided by, look at this, this is 1 plus 1 by x plus 1 by x square. Now plus under root of, this is 1 plus 1 by x square, right? Now look at this, I have created 1 by x and 1 by x square. Now I can find the things easily. Remember, when x approaches to infinity, this is 0, this term is also 0, and this term is also 0. So what I am left with is limit x tends to infinity. In the numerator it will be 1, and in the denominator it will be 1 plus, that term was 0 and this term is also 0, and this is 1 plus 0. So now this is limit n tends to infinity. No need to write limit now because all terms are independent of x now. So what I have, under root of 1 plus 1, which is equal to 1 by 2. So this is the solution of this question. So the thing is, always you try to bring 1 by x or 1 by n, whatever the case is, right? Now if you remember, I had given you a question in the last class. The question was looking like this. Many students have asked this question: infinity n factorial divided by n plus 1 factorial minus n factorial. Clear? So how to solve this question? This was an easy question. The thing is, I have told you in factorial set that try to bring the split the greater number and fix the smaller number. So n is the smaller number, so n factorial is fixed, and it will be written as n plus 1 multiplied by n factorial minus n factorial, right? So limit, this will be n tends to infinity. Now if I cancel n factorial in numerator and denominator, what will be left here? 1 divided by n plus 1 minus 1. So in that 1 and 1 will get cancelled, and I am left with only 1 by n, right? So 1 by n, when n approaches to infinity, 1 by n, it will be written as 1 by infinity, and the value will become 0 simply, right? So I think this concept is clear to you, right? Next, let me talk you regarding this important formula. This is very, very important, and we'll deal some questions. The question or formula looks like this: limit x tends to infinity 1 plus 1 by x raised to the power x, it is equal to e. Or in other words, if I want to write limit x tends to 0 form, then it will be 1 plus x whole divided by 1 by x is also equal to e, right? So in this case, what I have to do, whenever I am asked with this type of questions, first let me deal some questions which relates to infinity. Clear? So I have this one as my formula. Clear? So let us try a question here. If I ask you limit x tends to infinity 1 plus 1 by 2x raised to the power x, how to solve this kind of questions? Let us discuss. So for that, what I will do is, first I convert it into 0 form. Let 1 by x, it is equal to t, suppose. If, and you know, when I replace the terms like this, so I have to replace x as well as t. So I will write here, when x tends to infinity, our t will tend to 0. So the terms will be looking like this: limit t tends to 0, 1 plus t by 2 it will be written, because 1 by x is t and it is 1 by t. Is that clear? So this is my question now. So what I will do, I will take the entire term as y, right? That is, let y equals to limit t tends to 0, I repeat, limit t tends to 0, 1 plus, this is t by 2 raised to the power t. Now take log on both sides. If I take on log of both sides, it will be log y in this, and it will be limit t tends to 0, log of 1 plus t by 2 whole to the power t. So what I get is log y, it is equal to, if I bring t to the beginning, then it will be limit t tends to 0, it will be nothing but log, if I see, actually the question is a bit different, it will be 1 by t. In the previous page, you just make it as 1 by t, because it was x now, so it will be 1 by t. So it will be log 1 plus t by 2 divided by t, right? Now this is our condition. I rewrite it. What I get is log y it is equal to limit t tends to 0 log of 1 plus t by 2 divided by t. Now if I put 0 here, this will become log 1, which is equal to 0, and denominator is also 0. So this concept or this question has become in the form of 0 by 0. So for removing this one, what I will do is apply L'Hospital rule. So log y, it is equal to limit t tends to 0. This will be derivative of log 1 plus t by 2 divided by derivative of t. Which rule I have applied? That is called L'Hospital rule, which I have dealt in the previous classes. So try to understand it. Clear? So let us see the next step now. If I see the next step, this will be log y, it is equal to limit t tends to 0 derivative of log 1 plus t by 2. So this will be 1 divided by 1 plus t by 2 for logarithm multiplied by, if I take the derivative of inside, it will become 1 by 2, and in the denominator it is nothing but derivative of t, which is equal to 1. So I get here now log y, it is equal to 1 by 2 and limit t tends to 0 1 by 1 plus t by 2. So if I put 0 here, it will be 1 only. So what I have directly, this will be 1 by 2 only multiplied by 1. Now here the base is e, so I want to find y. Y is e to the power 1 by 2, which is equal to square root of e. So what was our e? That is the value of limit. So this one is the solution of this question. The final solution is under root of e. Is that clear? So I have to deal another question regarding this. If I have some negative values, please see how the question will be solved. If I have question is evaluate limit your x tends to 0 1 minus 3x divided by 1 by x. So what I should do is 1 by 2x, let us make it 1 divided by 2x. Clear? So what I will do, I will take the things first y. It is already 0, no need to convert it into 0. So y equals to let this term is equal to y. So take log on both sides. What I get? Log y, it is equal to limit x tends to 0 your log of 1 minus 3x whole to the power 1 by 2x, right? Now you know the property of log, that this will become limit x tends to 0 log of 1 minus 3x whole divided by 2x. Now what I will do is, this is becoming 0 by 0 form. Again I will apply your L'Hospital rule. So for applying L'Hospital rule, what I will take? I will take the derivative of the numerator as well as the derivative of the denominator. So let me rewrite the sentence once again. Log y, it is equal to limit x tends to 0 1 minus, it will be log 1 minus 3x whole divided by 2x. Clear? So for that, what I will have, log y, it is equal to, applying L'Hospital rule, I should write it as derivative of the numerator. The derivative of the numerator, 1 log derivative is 1 by, so 1 divided by 1 minus 3x multiplied by derivative of inside the derivative will be minus 3 divided by derivative of the denominator, it will be 2. What I have done, I have just applied L'Hospital rule and taken the derivative of the numerator as well as denominator. So what I get, log y, it is equal to minus 3 by 2, I am taking outside. Now remaining things will be limit x tends to 0 1 by 1 minus 3x. Now you can easily see, when I get or take x equals to 0, then this value will be 1. So this is nothing but 1 only. So if it is 1, so what I will do, this is base e, y will be nothing but e to the power minus 3 by 2. So this is the required limit of that question, e to the power minus 3 by 2. So this is how we apply L'Hospital rule to deal with the limit of infinity terms. Clear? So this is very important concept. What I am giving is 3 questions to solve. This is your homework. You solve these questions. Limit n tends to infinity 1 plus 1 by 4n raised to the power 5n, suppose, right? Then question number, this is 1. Question number 2 is limit x tends to infinity 1 minus 3 by x whole to the power, you make it 3x by 2, right? And your third and last question is limit x tends to 0 1 minus 5x raised to the power 1 by 7x. So these are the 3 questions which I have given as homework. Solve this, and in the next question you ask your doubts, we will definitely solve your questions. So I hope that you have understood this topic properly. Here we complete the topic limit, then we will proceed for the derivative related questions. Okay, that's all for today. Thank you very much.